It's a brief video on using inverse trigonometry when solving for an unknown angle within a right triangle. So I'm going to follow my directions off to the side here. You want to make sure that you identify your sides appropriately. So across from the box, that's going to be our hypotenuse. And then now we identify everything based off of the acute angle. So starting at the angle that's been identified, which is theta, we know that the 5 is going to be opposite. And then we want to identify the remaining side, which is the adjacent side. Okay, taking a look at the picture, it looks like we have no numeric values on the hypotenuse, so I'm just going to ignore that for the time being. I want to set up the correct ratio here. Okay, using SOHCAHTOA, I know that the ratio of opposite and adjacent is going to be tangent. So I'm going to rewrite this as tangent of my angle, in this case, which is theta, is equal to the opposite side, which is 5, over the adjacent side, which is 12. All right, we need to be able to get rid of tangent itself, so we want to do the inverse operation of tangent. Well, the inverse operation of tangent is tangent inverse, and we're going to apply that to the entirety of the equation. So tangent inverse is going to be applied to the left-hand side, and tangent inverse is also going to be applied to the right-hand side. You'll notice on the left-hand side, we have both tan and tan inverse right next to each other. As inverses, they are going to cancel each other out. So those knock each other out, which means we have the theta by itself. And we're just going to copy down what we have on the other side. So we have tan inverse of 5 over 12. If we were looking for the exact answer for theta, that's what it would be. However, we do want to see something that actually looks like a degree for us. So we're going to type this into the calculator, and the approximation that we're going to get is 22.6198. I did truncate. You could have actually turned that into 22.6199 if you would like to round. Okay, let's move on to the next question. A little bit more practice. Same idea. Start at the box, go across to identify the hypotenuse. Then we're going to start at the acute angle. So the angle that's been identified, go across from that, that's opposite. And then I do like to identify the adjacent as the last one. Remember that the adjacent is right next to the angle theta, but it is not the hypotenuse. All right, let's clear out the adjacent side here because there's no numeric value on there. And then I take a look at this and I have opposite and hypotenuse using SOHCAHTOA. That sounds like sine. So I would do sine of the acute angle, which is equal to opposite over hypotenuse. Okay, we need to be able to solve for the angle itself. So we need to get rid of sine. Well, the inverse of sine, or what undoes it, is just sine inverse. We're going to apply that to both sides, just like we did on the previous problem. So we'll do sine inverse of sine of theta on the right, and then we're going to do sine inverse of the right side. So we applied it on the left, we apply it on the right. The sine and the sine inverse that are right next to each other here that I just highlighted in purple, those are inverses of each other, so they are going to cancel. Theta is equal to sine inverse of 15 over 34. So that would be my exact value, but we do want to actually see what the degree is on this. So grab our calculator, we type it in. It looks like we're going to get 26.1789. I did truncate as well. So here are a couple of examples. Yes, you could do cosine as well. It just kind of depends on the setup of the problem.